Hello, Mr. Kitchen, Global Skill, Richmondville High School Physics. Today we're going to take a look at a comparison between the gravitational and the electric fields. Now the first thing we want to take a look at is whether they're vector or scalar fields. Vectors, of course, have a direction associated with them. And the gravitational field is a field of force, and as such, it is a vector. It turns out pretty much the same thing is true of the electric field. When we look at the electric field, we're going to be looking at the forces that are applied on electric charges, and it is also going to be a vector field. So we've moved away from energy and power and work and things like that. We were scalars, and now we're back into a discussion of some vector quantities. The next thing we want to take a look at are the field strength equations. And we should be familiar with gravity. Little g is the symbol that we use for the strength of the gravitational field. And to figure that out, we take the weight, or the force of gravity, and we divide by the mass. In essence, it gives us how much gravitational force you're going to get per kilogram of mass. And of course, that's measured in newtons per kilogram. Now, a newton per kilogram is also the same thing as a meter per second squared, but when we're talking about field strength, we use the newton per kilogram. For the electric field, we define the field strength equation in a very similar way. What we've got is the electric field is the electric force divided by, if you recall, Q is the amount of charge that we have. So it's force divided by the amount of the thing that causes that force. The units for that, for the electric field strength, are going to be newtons for force and then coulombs for charge. So electric field strength is in newtons per coulomb. Next, the direction of the field, and these are just definitions that people have come up with. For the gravitational field, it's the direction of a test mass. You take a small mass and you release it in the field, and you allow it to move slowly. You allow it to move with no acceleration. We don't want it to build up a lot of momentum. And the path that that mass traces out is defined as the direction of the field. At those points. For the electric field, we do the same thing. The only difference is for electricity, there are two types of charge. Of course, there's only one type of mass. So we had to make a definition. It was decided that we were going to use positive test charges. So the direction of a positive test charge, once again, we just release it in the field. We allow it to move slowly without acceleration, and that will trace out an electric field line and define the direction of the field. Here are our force equations. For gravity, we've got Newton's law of universal gravitation, big G, m1, m2 over r squared. And if you look at the electric field, that's Coulomb's law, but you can see mathematically they are very similar. The force is equal to a constant times the product of the two things that cause the force divided by the distance between the centers of those objects squared. And we do have the restrictions here. The gravitational equation that we're using only applies to point masses. The version of Coulomb's law we're using only applies to point charges, and that's because we're measuring the distance between the centers of those objects as a way of getting around doing some of the higher level math, some of the calculus involved. And finally, I've got two examples here, and I'd like you to finish these up and put the answers in your notes. You can give me a formula, then substitution with numbers and units, and an answer with units. For gravitational field, I'm asking you to find the gravitational field strength if a 1.4 kilogram mass weighs 2.2 newtons at a certain spot in the field. And then for the electric field, please find the electric field strength if 1.5 microcoulombs, that's 1.5 e minus 6 coulombs, has an electric force of 4.5 e minus 3 newtons. Finish these two up in your notes, and when I come around and check, I'll look for the solutions. Thanks.